We're going to talk about the modulus of elasticity, and last time we looked at the stress-strain diagram and looked at Hooke's law, which was all about elasticity and about how stress is proportional to strain. And in that elastic range of the material, that graph is a straight line, isn't it? The ratio of stress to strain is the slope of that straight line. And so stress over strain, that's a constant number. That's the slope of that line, no matter where on the line you look at it. Stress over strain. Well, that number, stress over strain, is the modulus of elasticity. It's the slope of that straight line. And the slope for mild steel is a constant number. The slope for aluminum is a different constant number. Each material has a straight line part of their graph and a slope to that straight line, and that slope is the modulus of elasticity. It's that constant relationship between stress and strain. And so here it is kind of boiled down. Elasticity is stress over strain, stress over strain, stress over strain, stress over strain. That's the modulus of elasticity. What is that a measure of? Floppiness, stiffness. Let's think about what units this is in. Okay, stress over strain. Stress is in psi, strain has no units, so stress over strain is psi over no units. We're still left with psi. So, okay, what we just saw is that modulus of elasticity, whatever the heck that is measured in psi. Here's the table of properties that we looked at last time. When we looked at mild steel, we looked at its yield stress and its ultimate stress. Now let's look at its modulus of elasticity. That is, its stiffness. So we looked at yield stress for tension and compression. We'll look at elasticity, or floppiness or stiffness, for tension or compression. Now, you might recall that last time we noticed that the chart says these numbers are in KSI. They are in 1000 PSI. So this number right here for mild steel is 29,000 PSI, or 29 million PSI. That's right. The modulus of elasticity for mild steel happens to be 29 million PSI. And don't worry that that's a big number. That's just the slope of the line. Stress over strain. Stress over strain. Here it is. Stress, great big number, over strain, little tiny number, means the slope of that line is a great big number, 29 million PSI. So what is all this about? Well, we are working our way towards thinking about how stiff or floppy items in our structures are. And there are two characteristics by which we measure stiffness. The stiffness of the material is the modulus of elasticity, stress over strain. That's what we're talking about today. The stiffness of the shape is moment of inertia. That's what we'll talk about next week. That's why is a wide flange beam more stiff than a piece of flat bar? Because of its shape. So modulus of elasticity is stiffness of the material. Moment of inertia is stiffness of the shape. And we can use this if we want to see Well, we put a steel beam in the floor of our building. How much will it deflect when we put a load on it? Will it sag too much? If we construct a building with a wood floor, how bouncy will it be? Will it be too bouncy? If we hang a weight from our cable on our crane, how much will it stretch? Those are all things we can do just by plugging that 29 million psi number. Well, if we're talking about steel, we can plug that number into our equation and find out how much will our steel deflect, how much will our steel stretch. That's why we're doing this.